Bird migration. The phenomenon of seasonal bird migration has been known about for thousands of years, but it is still not fully understood by scientists. Not all birds migrate, but generally speaking, the more northerly the breed ground, the more likely is that a species will migrate south for the winter. The main reason for this annual shifting of residence is that during the northern winter, food becomes scarce and the cold temperatures make survival difficult. Some species are well adapted to these harsh conditions, but for those that aren't, moving south to warmer conditions is advantageous. Changes in the weather can trigger the start of the journey south. Although birds in the northern hemisphere seem to know when it is time to migrate south before the winter. In fact, some species, at least, the changes in the length of the day cause glands in the birds' bodies to secrete hormones that produce other changes, which ready the birds for the long flight south. At this time, fat starts to accumulate under the skin, and this provides a store of energy for the long flight when they will be expending more calories flying than they can obtain during their brief rest stops. In fact, bird migration patterns are more complex than the simple pattern implied above. Birds that breed in the southern hemisphere migrate north to wintering grounds. Other birds travel on an approximately east-west path since milder climates can often be found in coastal areas of continental regions. Some birds find conditions more suitable at lower altitudes in a mountainous region and to migrate to lower levels in winter. Perhaps the most mysterious and yet not totally understood aspect of bird migration is how birds can navigate such long distances and arrive so precisely at their destination. Various possibilities exist. The most obvious explanation is that they learn the topographic feature of their route. However, it is not feasible that this method could be used for crossing larger stretches of water or very long trips across whole continents. Another possible explanation is that some birds may use magnetic fields. Scientists have actually detected tiny crystals of magnetic in the olfactory. Olfactory means connected with the sense of smell. Tract of some species and homing pigeons having been shown to follow magnetic fields line of the earth. A further possibility is that birds can detect the polarization patterns in sunlight. Some light waves from the sun are absorbed in the atmosphere and some pass through. The resulting pattern of light waves forms a large bounty shaped image in the sky. The image has fuzzy ends and is sometimes known as Hedinger's brush after the discoverer of the effect. The image is oriented in a north and south direction and is visible at sunset. Although birds may not see this shape, they can discern gradations of polarization, which give them a kind of compass for determining directions. Scientists believe that some birds navigate by use of star positions. This has been established with at least one species. In a series of studies, caged birds were subjected to the projection of the nighttime northern hemisphere inside a planetarium. All stars rotate around Polaris, the pole star, and this movement seemed to give the birds the information they needed to orientate themselves in the correct direction. However, some recent research contradicts this. Perhaps it is not the lack of movement of the pole star, but rather the constellation patterns that guide them. It has also been found that when fewer stars were visible on the planetarium ceiling, the birds seemed to sense of direction become poorer, and this too implies that the general star pattern does have some bearing on orientation. The current state of research suggests that all of the above methods probably have an influence on bird migration. Different species use one, some, or even all methods of different times and various situations.